That means, okay. So hello everyone again. Welcome to another PG live stream where we will be discussing about rookie mistake machine. I'm your host for today. It's me again, Mobius. For those who just joined the first time, I'm one of the student mentor, and I've been in OffSec for 5 years and running. So a bit about the machine we are trying I'm trying to give the walkthrough is the rookie mistake is PG practice machine. So you probably need a subscription. And let's see. Wait a minute. So why? Oops, sorry. So a little bit about myself. As I said, I'm Mobius. Been 5 years in here, and I have been known as Crates as well. For the first few years in OffSec, I used this handle name. You can find me at Discord, and usually I'm supporting the Pen 200, Pen 210, and SOC 200. Sometimes also work in Web 200. So I think that's about me. Yeah, quick for our agenda. Let's see. For our agenda, we will have enumerate the machine, and we'll try to exploit it. And there's will be a Q&A. So, since we are trying to target PG practice machine, I said that you need the subscription for it, right? Good things that in the end of this walkthrough, a prize for lucky winner will be given. So if you don't have access to PG, stay tuned until the end. So I've already started my instance here, but if you're wondering where it's located, you can navigate to your portal, clicking Explore, Labs, Proving Ground, and Practice. And you will be landing on this page. Just search for the rookie, and you will find the machine. So without further ado, let's get to work on this machine. I already have my VPN right here, and I will be first trying to ping the target. So our target is 192.168.214.221. There, we confirm that the host is available. Now, let's nmap this IP address without any option at all. So we want to really quick scanning the port, and then after that we will start a next scan. This will be taking, I think, a minute. In the meantime, I will, yeah, there we go. So we discovered two open port here, the port 22 and port 8080. Now, let's try to scan. this time we will use surface detection to scan the version. Also, I will be skipping host discovery with -pn. And what we want to also, we try to scan the OS. And finally, running script to these two ports, 88E, and then, yeah, sorry. Okay, while this is running, I'm going to, let me see. Let's see. Okay, this could take some minutes. Yeah, we can use verbosity with dash VVV, but yeah, just pressing enter here, it will be showing you the current status or something. So bear in mind, I may have a mediocre internet connection. So yeah. Any moment now, you think? No, it took longer than expected. So yeah. So let's just discuss the output that we have in here. So there's a port 22. There we go. So the port 22 reporting that there's an open SSH 8.2. SSH isn't really that interesting because it has a small surface of attack. I can only think of brute force at this moment with SSH, but since we don't have any known username, we will be skipping this attack at the moment. Instead, let's look at the port 8080. It shows a WordZoop Python 3.8 seems to be a web server. So it's a web server powered by Python. And yeah, there's nothing else. We can see that they're probably using some templates here. And yeah, apart from that, we knew that this target machine will be a Linux machine. So this port 8080, I think it has an interesting result. And since it is a custom web page, this should be having a much larger surface area to attack. So I will be firing the Firefox, and we will try to access this target IP address. And as you can see, nothing much here. There's no link. We can inspect the source, but there's nothing really helping us here. So let's run a tools to enumerate the web directory. I will be using the GoBuster here, but any tools such as Deerbuster or Derp should work too. So putting GoBuster, I will using directory dash use tp 192.168.4. And we will use the word list of user share word list directory. Oh, dear Buster first. Oh, I'm going to use probably this one. Okay. So we can already see something right away. There is a login page, the sign up page, and yeah. Let's inspect this one and see what else should come up. So I will be accessing login here. It appeared there's a login form. We don't have the user yet, so let's work with sign up. There's an edit as well, so yeah, we will definitely inspect that. So I will be accessing sign up. Okay, sign up. There's also two prompt here, same like login. Let's try to enter something and something as a password here. If we submit, it only say successfully registered. Seems not much, but let's try login using the credential that we supplied earlier. If I put something here and something, it will say that I am successfully logged in, but not really that much. The last thing is there's an edit page. We don't know of this, so let's access this as well. Okay, this time the page suggests that we can edit our password and it automatically somehow recognize us as the user something. Let's dig deeper this time. We will be using burp, so we can inspect what happened in the background. I will be proxying my connection into the burp. And probably I will be let's see if we can, yeah, okay. I think there's an option to extend the, I mean, like enlarge the font of the burp. Let's see, yeah, font size. Let's work with 80, 18, 18, yeah. Okay, so we proxied our connection to burp. We making sure that there is no intercept on. So let's see the edit page once again. I will be refreshing this. And we can see the HTTP response and HTTP requests. So if you check here, not sure, is it really readable on your side, everyone? Let's see. Okay. Cool. Thanks for the confirmation. So as you can see here, these requests, we got assigned a cookie called token. And there's this text here where this is appear to be a JWT token. So how can we identify this as a JWT token? So typically, the JWT token consists of 3 parts, and it's separated with a dot in between. So if you can see here, there's a dot, and also there's a dot. These 3 parts is actually the header, this payload, and the signature. It's encoded in base 64, but if you try to decode it as a fully, you won't see any encoded part here. You need to select it manually so you can know what this is all about. So if I select the character until the dot, you will see here that the decoded message was the type, JWT, alt, stand for algorithm. It's HS256. Also this one, if you select just before the dot, you will be knowing that this is the payload. It shows you the username, it's public ID, which we don't know of this yet, and the EXP, mean the token expire. This number is actually the date. So if you copy this one and just try to convert it into Unix timestamp, it will show you the actual date. I mean, like, let's just quickly check that. So if you put it right here, then it will show you the when the token is actually expiring. Okay, moving on. Last is the signature, where we cannot really decode it because signature contains a secret key. So this actually expected because we don't know the secret yet, but there is a page called JWT token, JWT IO, where we can copy this token and paste it right here. So we know that, yeah, we know that the content of the JWT token itself. So same like the burp, but this is much nicer to work with. And second thing that I want to provide, I want to focus on is when you see the edit page, you can see that there is a username reflected to this, right? So if we manage to somehow changing the content in here, what will happen? So I will try to change something in here into, let's say, example, and try to copy this. And we will be sending this to repeater, so we can repeat the request. I will be changing the payload and send. Let's just render it so we can have a good, so it would say an invalid token. Why? Because we don't have the secret key. So although we can tamper the JSON payload in here, the signature, it says it's verified, but I mean, like the application, the web application that on the target machine won't be able to verify the message was true or not, because it's not encrypted with our secret key. So what can we do in this case? So one thing that we can do, let's copy the original token that we had. And I will be stopping this. And let's put the, okay, that's bad. Just let's write the token in a file called jwt.hash, and then using John, we can actually crack the secret keys. John fortunately recognize this key format. So John jwt.hash, and I will be specifying the wordless. And there we go. John actually can crack the secrets of the JWT token that we have. And it discovered that the secret was, I love JWT. So right now, let's try to, let's see, go to JWT IO again and change, let me change it into something like the secrets that we had earlier. So this time, the username is example, which we already know that this user is not exist. But since we have the secrets now, I think we can make the request verified, and instead of getting invalid token as a response, we probably get something else. So let's try. And I will be pasting the new modified payload. When I put send in it, you can see that it actually mentioning changing password, for example. So this this thing, there's a two thing happening here. First is we can successfully modify the token and control what we can input. In this case, the username. And two, notice that we put the username in here. Yeah, in here, I mean, with the token, it got reflected in the web page. But we still don't have a shell, but luckily we can assess if this web page has SSTI vulnerability. So SSTI, or server-side template injection, is a vulnerability where you can inject codes, whether it's Java, it's PHP, or Python, and let it execute the code on the server side. The difference, unlike the XSS, which pretty much the same, but you inject the code in here and it got execute. But XSS execute on client side, right? It execute on user browser, where the SSTI, the code itself will be executed on server, means that if you put something, it will directly give you the RCE, and you can abuse the RCE to get a shell in here. So to quickly identify if the web page has SSTI vulnerability, I will be checking the Hectrix. Hectrix has the compile command of everything. So this site, I think, is worth to check. So I will be using, this is the tools. You can use SSTI map or something, but we know that this is powered by Python, right? So let's run, let's search for the Python. Let's, okay, this is PHP one. Python, yeah. So we can try to use this payload and see if the output is here. If it show the output, it means that the Python is actually executing the code. So I'm going to go back to JWT.io. Instead of example, we will use this character. I don't know how to pronounce it. 7 times 7. And make sure the secrets are there, and we copy. We will be copying this modified one, and let's run this once again. There. So interesting that we put 7 times 7. It shows us the 49, which somehow the web backend processing our username, what we put in username. And this is also proof that there's an execution in there. Somehow it processed our request. So instead for using this payload, let's go back to the Hectrix again. let's see if we can use the RC. So it actually abusing the booleans configuration, it seems. We can use this one, but yeah, let's try to use this one. It's the same one, I think, cycler. It's just the, you know, the full path is here, but this is the reference part. So let's just copy this one. I'm going back to JWT again and change the arithmetic payload into something like this. So let's copy this once again and change the token. And we send the request. As you can see there, you can get the output of the ID command that we provide. And this is actually, we can confirm that this is an RCE. The only things that left is we need to get a shell. So for this, we will have to use the command. We will have to change the command into something like, oh, sorry for that. NC and my attacker IP, which is right here, 192.168.45.236. I will be using port 4444, where it will execute /bins and bash. Let's copy this again and change this. Don't forget to get a listener ready. Okay, when I click this, when I send a request, it should be giving me the shell, right? There's nothing saying that there's an error, but we didn't really get a shell in here. So, okay, this can be happening because a few things. I mean, like one of the reason probably because the NC wasn't, we didn't using the full path maybe, or maybe the NC didn't support the -E. But let's find a way that we can use to get a shell. So I will be creating a file called rookie.sh, and I will be using bash. Let's see, bash. I will be using one-liner payload, which is this one. And we will redirect everything. So yeah, I'm creating a rookie.sh, and then we will try to call the rookie.sh in here. So I will be hosting the file, and then instead of using NC, we will be asking the file from my IP address, and then piping it into bash, so it directly execute the bash script that we provide. Going to copy this once again. And sending it out. There. You can see that it actually got a shell right now. So our payload works. And yeah, we got a shell as Mike in here. Let's see what's inside. So yeah, it got an app. Let's quickly inspect. It's my bad habit actually. It's not a bad habit. It's a habit actually. When I first pop into a machine, I didn't really straight to go to check whatever things like that. I checked what was inside of this one because yeah, curiosity. I mean. So this app.py is actually the seems like it is the actual application, right? You can see that the secrets in here. And then, yeah, we don't have to really understand this, but this is the actual code that is that is running on the web app. So good to know. And also, let's see again. Okay, so let's go back a bit and let's see what file in it. Okay, so we can check there's local here, which indicates that we got initial foothold on this machine. We can put this on the portal, but there's an interesting things called to do as well. So let's quickly check that. Okay, so there is a to do, probably some message that from someone to Mike here, I assume. It says that remove having the secret within the JWT after testing and debugging, which Mike actually remove that and figure out a secure way to utilize root permission for the PID monitor. So, okay, somehow Mike is creating a way to monitor the PID, and it use a root permission. So let's check. Yeah, this is Mike, right? Okay. Let's check what Mike can, let's list what binary that Mike can execute. So we can see here that Mike can actually access this one with no password. So, but we don't really know what this is. So, okay. So, okay. So before we going to, I mean, like executing this is the next step that we should do, right? We want to get to another shell. I will be opening another one in here because I don't know what's this app will be if we run this. If we run this, we might lose our shell. So it's better to have another shell, right? So for this, I will be running NC perhaps 192.168. My IP address again 45.236. And executing in .bash again. Oh, okay. So yeah, As you can see here, there's an nmap error called -e. It is invalid option. So this is actually the new netcat where they removed the -e option because it been used for reverse shell. But typically, distribution should have another NC, which I think, which we can, yeah, the NC is in here. So NC, another NC will be here as well, but it is name traditional. Oh yeah, that's the thing. (45%) Okay, I intendly to make this an error so we can get back to this one. So let's try to use this. And this time, I think this should work. Ah, there we go. Yeah, so we have another shell. I mean, like this is an optional because, we don't know if we execute some kind of application, it will be, just making sure that we have another shell for backup so we don't need to exploit it. So I will be upgrading the TTY here with Python one-liner. And this time, in the left side, I will try to control C. Yeah, we get back to that, right? Okay. Let's clear that out again. Start again. And let's use the same payload again. But this time we will be backing up that with N here. So it will be straight going into the background. Yep. And then the Python. Okay. Yeah, we had a 2 shell. So for safety measure. Okay, so back again. I will try next for this. See if we can figure out what this is process actually about. Okay, there we go. So it shows us access my own process monitor. Server started at port 9123. Okay. Somehow the service running at port 9123, so better check with that port, right? Yeah, we have the, yeah, as you can see, the left shell that we had, it stopped. Probably we control C this, it will be, terminating. Good things that we have the backup, right? And quickly checking the port 9123, we can figure out that there is a surface. It should be the PID monitor. But let's just try to curl this, access this. And what happened? Okay, so it shows us the banner. Welcome to my PID status monitor. Can you specify the PID in the URL? So it requires /PID/ numbering in here. So let's just try to access that once again. This time with PID, and let's try 1. Okay, so it actually executing, getting the status of PID 1. But yeah, nothing in here because probably there's no PID 1 in here. This is not something that we want to check for, but we will try to, let's try to put a non-existent something in here because it requires a numbering, but how about we put a letter? Okay, as you can see here, it shows us the error. I think the error message is the usage, and it tells us the binary that it actually used. It's PID stat. Okay, and PID stat because we put illegal character in here. So since we know that this is the PID stat, there's a site as well. It's called GTFO bin. It's actually a curated list of every binary that can be used to that has the feature that can be abused to get privilege escalation. So let's try to check if, yeah, there's a PID stat in here. Let's get to that. So it can break out from restricted environment running non-interactive system command. So just putting a -e and put our command in here, which the command was ID in here, it will be executing the that command. So let's just try that. Let's just try that. For this, I will be Control-C because we probably don't really need that anymore. And curl this one. We will be modify. It needs to be accepting the input, right? So if we're having syntax error, it will not be executed. So we put numbering 1 here because we know that PID 1, it got executed. And then -e, and the command that we need to use, let's use, this one. Let's just copy this one again. Okay. And I will be setting my listener. But as you can see, there is a space right here. So we need to avoid that this will be an issue. So I will just copy this part, this payload right here. And let's URL encode that. Oh, yeah. Okay, so this is the encoded part. Let's make sure I introduce line break there. Okay, this one. Let's just copy this. And then instead of using that, we will be, no, okay, that's an error. 192.168, no, sorry, 127.0.0.1.1.9.2.3, PID and our payload. So if this worked, we will get a shell in 4444, but since this is running as root, we should be getting root instead of mic. So let's just run this one. And we got a shell. I will be reusing the Python here and put that in here. Okay, there we go. So we actually get the root this time. And the proof should be in here, right? Okay. There we go. So we did manage to abuse the PID stat and get the root access for the mic server. And that's it. We found that there is a proof, and also, what's this build, right? Let's look at this one again. I'm more interested with that one. Okay. Okay, since this is not something that you should be looking at, yeah, this is probably the script, you know. Yeah, but yeah, we already get the proof, so that's about it. This marked the end of the walkthrough. I hope that you really enjoying this one, and I hope that really you learned something from this one. It appeared to be I don't know, an easy box for you perhaps, but yeah, that's about it. And we come into the near session, but I am actually there is a quiz. I think there's a three questions that I have to provide, and the winner will be getting 1 month of PG practice subscription. So yeah, let's get into it. Are you guys ready? I will be saying the question, and you provide the answer in the chat box. When you are the winner, yeah, thank you for the if you are a winner, the OffSec official account will be PMing you, whispering you. Okay, okay, cool. So first question, in the JSON request that we worked with earlier, what is the parameter that we use to what parameter that we use? I mean, like, I need to rephrase that. I mean, what's the parameter that we actually use for exploiting the SSTI? Yeah. Okay. I can see that the Pebble got it the first time. So congrats, Pebble. OffSec official will be I mean, like okay. Second question. What will be the second question? So what is the file name, the Python file name that is actually used to host the login, sign up, and edit the app py? I'm actually forgetting that, but I think, does it in app py? we still have a shell, right? Oh my, yeah, I know. Yep, FBI. So, student 2024 underscore A, you are the first one that answering correctly. And last time, I think this should be an easy one. What is the SSTI stands for? You pre-fired that one. Yeah. uh, yeah. Subute. Yeah, Cyber Subute will be the winner since Pebble already win one, and he actually had a typo in there, so he will. It is not correct. So, surfer. No, no. Actually, Cyber Subute, you also had a typo. So PhD builds. It's actually server side. Yeah, you also had a typo. Oh my. Okay, so Max Store. Max Store is the winner. Yeah, yeah, yeah. Max Store. Yeah, that's unfortunate. Yeah, okay, but yeah, congrats to the winner, student 2024 underscore A, PA. I mean, like Max Store. And also the first winner was Pebble. Yeah, Pebble. Yeah, congrats to all the winner. And yeah, that's the end of the session. For the winner, please stay a bit long until you a bit longer until you have been whispered by the OffSec official. And that's the end of the stream. Yeah, I hope you're learning something and enjoy. Mobius here signing out. Have a good one. Have a great weekend, everyone.